How to calculate the number of molecules in 0.50 megagrams of sulfuric acid H₂SO₄. In this case, we will solve the problem using two techniques, the chemical conversion factor and algebraic theorems. We will start with the chemical conversion factor. The first step is to write the given data in the format of the chemical conversion factor, where each term consists of a value, a unit of measure, and a substance identity. In this case, we have 0.50 megagrams of sulfuric acid. Then, we multiply by the first conversion factor, which consists of placing megagrams of sulfuric acid in the denominator and grams of sulfuric acid in the numerator. Since a megagram is a larger unit, we establish that 1 megagram equals 10 to the power of 6 grams. In the second conversion factor, we place grams of sulfuric acid in the denominator and moles of sulfuric acid in the numerator. Here, we assign the theoretical unit to the mole and determine how many grams are in a mole. The answer to this question is the molar mass. To calculate the molar mass of sulfuric acid, we sum 2 times 1.01 for hydrogen, 32.07 for sulfur, and 4 times 16.00 for oxygen. The result 98.09 is expressed in units of gram per mole. In the next conversion factor, we place moles in the denominator and molecules of sulfuric acid in the numerator. Again, the mole carries the theoretical unit, and the number of molecules in a mole of any substance is always Avogadro's number, which is 6.022 times 10 to the power of 23. In dimensional analysis, we eliminate units and ones that multiply and divide. If any unit has significant figures, they must be taken into account. We extract the significant values to enter them into the calculator and perform the arithmetic. Now we solve the arithmetic 0.5 times 10 to the 6 times 6.022 times 10 to the 23 divided by 98.09. The result is 3.06 times 10 to the 27, which we round to two significant figures, that is, 3.1 times 10 to the 27. To apply the theorem, we select the corresponding one from our formula sheet, which indicates that the number of molecules, represented by italic N subscript J, is equivalent to the product of Avogadro's constant times the given mass divided by the molar mass. We simply follow the equation. In the formula, we substitute J with the identity of the substance, which in this case is the molecular formula of the substance. Then, we substitute Avogadro's number with 6.022 times 10 to the power of 23 in units of 1 per mole, the mass with 0.5 megagrams, and the molar mass with 98.09 grams per mole. Additionally, we substitute mega with its definition, which is 10 to the power of 6 positive. This comes from the table of decimal prefixes. Note that in this method the identity is contained in the dependent variable and does not need to be placed in the operational terms. When performing the dimensional analysis, the units cancel out, which makes sense because in algebraic form the number of entities is a dimensionless parameter. This differentiates it from the form of conversion factors. By eliminating the ones, we find that the significant terms are the same as those generated by the conversion factor, so the value is the same, 3.1 times 10 to the power of 27. In this case, it is implied by the italic uppercase N of the theorem that we are talking about entities of sulfuric acid. Since sulfuric acid is described as a molecule, we are implicitly talking about molecules, without needing to express it with units and identities as is done with conversion factors. Since the only real data is 0.50 megagrams, we count only two significant figures, and the answer is given in two significant figures because the 0 on the left is not significant, but the one on the right is. Well, that was all for now. If you liked the presentation, don't forget to subscribe, like, and share it. That keeps this channel alive. See you next time.